Hello children, now let us understand relative motion. First, relative position. Consider two particles, particle A and particle B in 2D Cartesian coordinate plane. Position of A is given by vector RA and position of B is given by vector RB. RA represents position of A with respect to origin and RB represents position of B with respect to origin. Then position of A with respect to B is given by vector RA, B, and that is equal to vector RA minus vector RB. Similarly, position of B with respect to A is given by vector RB, A, and that is equal to vector RB minus vector RA. Relative position can be represented in either of these two ways, as vector R A, B or vector R A /B. Now let us understand relative velocity. We will consider four scenarios. Scenario 1. Consider two particles, particle A and particle B. They are moving towards each other along the line joining them with velocities VA and VB respectively. Then velocity of A with respect to B is given by vector VA, B, and that is equal to vector VA minus vector VB. This can be written as vector VA plus of minus vector VB. Minus vector VB will be opposite of vector VB. So this vector represents vector VA, B, where magnitudes of both the vectors will be added and direction will be that of vector VA. Second scenario, consider two particles A and B are moving away from each other along the line joining them with velocities VA and VB respectively. Then velocity of particle A with respect to B is given by vector VA, B, and that is equal to vector VA minus vector VB. This can be written as vector VA plus of minus vector VB. Minus vector VB will be opposite to vector VB. So this represents vector VA, B, where magnitudes of both the velocities will be added and direction will be that of vector VA. Third scenario, consider two particles, particle A and particle B. They are moving with velocities VA and VB, making an angle alpha and beta respectively with the line joining them. These particles may or may not collide. However, at certain point of time, they will be at a minimum distance with each other. Then we say velocity of approach is component of vector VA, B along the line joining A and B. Magnitude of component of vector VA, B is equal to VA cos alpha minus VB cos beta. Fourth scenario, consider two particles, particle A and particle B. They are moving with velocities VA and VB, making an angle alpha and beta respectively with the line joining them. You can see that these particles will never collide. So we say that velocity of separation is component of vector VA, B along the line joining A and B. So magnitude of component of vector VA, B will be equal to VA cos alpha minus VB cos beta. Now let us understand relative acceleration. Consider two particles, particle A and particle B are moving with accelerations AA and AB respectively. Then acceleration of particle A with respect to B is given by vector A, B is equal to vector AA minus vector AB. Similarly, acceleration of particle B with respect to A is given by vector A, B, A, and that is equal to vector AB minus vector AA. Now let us see how to calculate minimum distance between two moving objects with the help of this question. Two bikers are standing on two mutually perpendicular roads at a distance of 100 meter and 60 meter respectively. They start moving towards intersection at a speed 25 meter per second and 10 meter per second respectively. Calculate the minimum distance between them and time taken to reach it. Suppose these are two mutually perpendicular roads. Their point of intersection is O. Biker A is standing at a distance of 100 meter from O and biker B is standing at a distance of 60 meter from O. At t is equal to 0, distance between them is AB. At t is equal to 0, biker A starts moving towards O with a speed 25 meter per second and biker B starts moving towards O with a speed 10 meter per second. We have to calculate after what time distance between them will be minimum. Suppose that distance is S. In time t, the distance traveled by A will be 25 t meters and by B it will be 10 t meters. So now distance between them, that is S, is equal to under root 100 minus 25 t whole square plus 60 minus 10 t whole square. For minimum or maximum S, ds by dt should be equal to 0. So we will do ds by dt. So ds by dt comes out to be this. And value of t comes out to be 4.28 seconds. Put this value in this. So minimum distance will be 18.57 meter. Now let us see applications of relative motion. First scenario is relative motion in river flow. We will consider two cases in it. First case, upstream downstream motion, and second case, across the river motion. First case, suppose river is flowing with velocity v and a swimmer is swimming with velocity u along the flow. Then relative velocity of swimmer with the stream will be u plus v. If the swimmer is swimming with velocity u but against the flow, then the relative velocity of swimmer against the stream will be u minus v. Second case, across the river. Suppose swimmer is standing at point A. River is flowing with velocity v. Swimmer can swim with velocity u. Swimmer wants to end up at point B. That means he or she wants to travel minimum distance. Then swimmer should start swimming at an angle theta with line AB. Suppose swimmer wants to cross the river in minimum time, then the direction of swimmer should be along the line AB so that he or she ends up at point B dash. Distance between B and B dash is called as drift. Now let us see these two questions based on relative motion in river flow. First question, a river 400 meter wide is flowing at a rate of 2 meter per second. A boat is sailing at a velocity of 10 meter per second with respect to the water in a direction perpendicular to the river. Part A, find the time taken by the boat to reach the opposite bank. Part B, how far from the point directly opposite to the starting point does the boat reach the opposite bank? Suppose this is river. Width of the river is given as 400 meter. Velocity of river water is v. Velocity of boat is u with respect to water. It is sailing along the line AB, that is perpendicular to the flow of water. Now time taken in this case will be minimum time. So time taken will be distance upon velocity of boat with respect to water. So that is equal to 400 upon 10, that is 40 seconds. Part B, how far from the point directly opposite to the starting point does the boat reach the opposite bank? Since the boat is sailing along the line AB, so because of flow of the water, it will end up somewhere at point B dash. So we have to calculate BB dash, that is drift. And drift happens because of the flow of water. So drift BB dash will be velocity of water into time taken by the boat to cross the river. So it will be 2 into 40, that is 80 meter. So BB dash is 80 meter. Second question, a swimmer wishes to cross a 500 meter wide river flowing at 5 km per hour. His speed with respect to water is 3 km per hour. Part A, if he heads in a direction making an angle theta with the flow, find the time he takes to cross the river. Part B, find the shortest possible time to cross the river. This is the river. Let us assume v is the velocity of river. U is the velocity of swimmer with respect to river water. He starts in a direction making an angle theta with the flow of water. Velocity component that counters the flow of water is u cos theta, and velocity component that helps to cross the river, that is along line AB, is u sin theta. So time taken by the swimmer in this case will be distance 500 upon velocity component along line AB, and that is u sine theta. U is given as 3 km per hour or 3 into 5 by 18 meter per second. So T is equal to 500 upon 3 into 5 by 18 sine theta. So T comes out to be 10 upon sine theta minutes. Part B, find the shortest possible time to cross the river. To cross the river taking shortest possible time, swimmer has to head in EB direction. So in that case, time taken will be 500 upon U. U is 3 into 5 by 18 meter per second. So it will be 500 upon 3 into 5 by 18. That comes out to be 600 seconds or 10 minutes. Now let us see these two questions to understand relative motion in wind. First question, an aeroplane has to go from a point A to another point B 500 km away due 30 degree east of north. A wind is blowing due north at a speed of 20 meter per second. The air speed of the plane is 150 meter per second. Part A, find the direction in which the pilot should head the plane to reach the point B. And part B, find the time taken by the plane to go from A to B. This is north, this is south, this is east, and this is west. A plane has to start from point A and reach point B, which is 500 kilometers away. Line AB makes 30 degree with north towards east. Suppose pilot starts flying in AC direction, which is theta degree from line AB. U is the velocity of plane and V is the velocity of wind. We will resolve U and V into two components, one along line AB and another perpendicular to it. Perpendicular to it components will cancel each other and along the AB will help reach the plane towards the target. So U is given as 150 meter per second, V is given as 20 meter per second. Component of U along the line AB will be U cos theta and perpendicular to it will be U sin theta. Similarly, component of V along the line AB will be V cos 30 degree and perpendicular to it will be V sin 30 degree. So perpendicular components will cancel each other. So U sin theta is equal to V sin 30 degree or theta is equal to sin inverse 1 by 15 east of line AB. Part B. Now adding these two components means U cos theta and V cos 30 degree, which will help the plane reach the target. So T is equal to AB. AB is given as 500 kilometers. So 500 into 10 to power 3 meters upon U cos theta plus V cos 30 degrees. So after calculation, T comes out to be approximately 49.9 minutes or 50 minutes. Second question, two friends A and B are standing a distance x apart in an open field and wind is blowing from A to B. A beats a drum and B hears the sound even time after he sees the event. A and B interchange their positions and the experiment is repeated. This time, B hears the drum T2 time after he sees the event. Calculate the velocity of sound in still air V and the velocity of wind U. Neglect the time light takes in traveling between the friends. Suppose A is sitting here with drum and B is here. Distance between them is given as x. Wind is blowing from A to B with speed U and sound travels with speed V. Now in case 2, they interchange their positions. A comes here with drum and B is here. Distance between them is same. Wind direction is also same. Direction of sound changes. So in case 1, wind and sound direction is same. In case 2, they are in opposite directions. In case 1, velocity of sound relative to wind will be V plus U. In second case, velocity of sound relative to wind will be V minus U. So in case 1, time taken for sound to travel from A to B will be T1. So T1 is equal to x upon V plus U. In case 2, T2 will be equal to x upon V minus U. Now solving these two equations for v and u, v comes out to be x by 2 in bracket 1 by t1 plus 1 by t2, and u comes out to be x by 2 in bracket 1 by t1 minus 1 by t2. Now let us see this question to understand relative motion in rain. A man standing on a road has to hold his umbrella at 30 degrees with the vertical to keep the rain away. He throws the umbrella and starts running at 10 km per hour. He finds that raindrops are hitting his head vertically. Find the speed of raindrops with respect to part A road and part B the moving man. Suppose man is standing here holding his umbrella like this because the raindrops are coming from a direction which is 30 degrees from the vertical. Now the man throws his umbrella and starts running in this direction, so the raindrops appear to be falling on his head vertically. Here V r, g represents velocity of raindrops with respect to ground. V m, g represents velocity of man with respect to ground, and V r, m represents velocity of rain with respect to man. We will resolve VRG into two components, one vertical component and one horizontal component. We will equate horizontal component with VMG and vertical component will be VRM. In first part, we have to calculate VRG, and in second part, we have to calculate VRM. So horizontal component of VRG will be equal to VRG sine 30, and that will be equal to VMG. So VMG is equal to VRG sine 30. So VRG comes out to be 20 km per hour, as VMG is given as 10 km per hour. In part B, VRM is equal to VRG cos 30. So VRM comes out to be 10 root 3 km per hour. Now let us understand relative motion in moving platform. We will consider two cases in it. First, when the platform is moving horizontally with uniform speed, and second, when platform is moving vertically with uniform speed. First case, consider a trolley is moving horizontally with uniform speed v. A person A is standing on the trolley holding a ball, and observer B is standing on the road. We will consider three cases in it. First, when person A throws the ball vertically upwards. Second, when the person throws the ball making an angle theta with the horizontal in the direction of movement of trolley. In third case, person throws the ball making an angle theta with the horizontal but in opposite to the movement of trolley. In case 1, person A will see the ball moving either in vertically upwards or downward direction. Observer B will see the ball moving in a parabolic path. Here the horizontal component of ball's velocity is equal to velocity of trolley. In second case, for A, horizontal component of ball's velocity will be u cos theta and vertical component of ball's velocity will be u sin theta. For B, horizontal component of ball's velocity will be u cos theta plus v, and vertical component of ball's velocity will be u sin theta. In this case, for A, horizontal component of ball's velocity will be u cos theta and vertical component of ball's velocity will be u sin theta. For B, horizontal component of ball's velocity will be u cos theta minus v, and vertical component of ball's velocity will be u sin theta. Second case, when platform is moving vertically up or vertically down with uniform speed v. In both the cases, suppose person A throws the ball at an angle theta with the horizontal. Then in this case, for A, horizontal component of ball's velocity will be u cos theta and vertical component of ball's velocity will be u sin theta. For B, horizontal component of ball's velocity will be u cos theta and vertical component of ball's velocity will be u sin theta plus v. In this case, for A, horizontal component of ball's velocity will be u cos theta and vertical component of ball's velocity will be u sin theta. For B, horizontal component of ball's velocity will be u cos theta and vertical component of ball's velocity will be u sin theta minus v. Let us see this question. A person is standing on a trolley which moves horizontally with uniform velocity 3i meter per second. At t is equal to 0, person throws a ball with velocity 3 cos theta I plus 3 sin theta j meter per second with respect to himself. He always sees the ball overhead. Then theta is equal to what? Suppose trolley is moving horizontally with uniform velocity 3I meter per second. A person who is standing on the trolley throws the ball making an angle theta with the horizontal such that u is equal to 3 cos theta I plus 3 sin theta j. This matches with first scenario. In this case, person throws the ball vertically upwards and he sees the ball overhead, either moving up or moving down. In this case, horizontal component of ball's velocity is equal to velocity of the trolley. So in this case also, horizontal component of ball's velocity should be equal to 3I. That means 3 cos theta should be equal to 0. That means cos theta is equal to cos 90 or theta is equal to 90 degrees. That means person should throw the ball vertically upwards. So theta is equal to 90 degrees is the answer. Now let us see relative motion in lift. We will consider two cases. Case 1 when lift is accelerating upwards and case 2 when lift is accelerating downwards with constant acceleration a. In case 1, a person who is standing in the lift experiences a upwards and g downwards. So net acceleration upwards will be a plus g. In this case, person experiences both the accelerations downwards. So net acceleration that will be equal to a minus g downwards. Let us see this question. A coin is thrown up in a lift with a velocity u relative to the lift and the time of flight is found to be t. Find the acceleration with which the lift is moving up. It is given that lift is accelerating up. So the coin experiences a upwards and g downwards. Net acceleration or relative acceleration on the coin will be equal to a plus g upwards. Consider relative movement in y direction on the coin. So y relative is equal to u relative t plus 1 by 2 a relative t square. U relative is given as u. Y relative will be displacement of coin with respect to lift and that is equal to 0. A relative is a plus g. Since the coin is coming down, so a relative will be taken as minus. This gives a quadratic in t. So either t is equal to 0 or this whole is equal to 0. T cannot be equal to 0, so this whole is equal to 0. This gives value of a as 2u minus gt upon t. In next video, we will solve previous year's JEE questions. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.